Good morning, lovely human. Let's talk about quantum mechanics because it's super cool. Okay, so one of the reasons why I love quantum mechanics is because it's non-deterministic. Basically, even if we have all of the information, we can't predict the outcome. So, unlike kind of traditional physics or classical physics, like mechanics and momentum and things like that, where we can calculate the precise landing spot of, say, a Mars rover, or if we throw a ball, something like that, we know what's going to happen. We can calculate that because we have really accurate theories. But in quantum mechanics, we can have all of the information that we need to calculate the wave function of a particle. And the wave function, basically, if you do a little bit of things, you square the magnitude of it. It gives you a probability function. So we can know the possible places that the particle could be. We can know possible outcomes, and that's kind of cool because we can know what's possible and what's not possible. There are things that are not possible in this universe, but any of the possible outcomes are, well, possible, right? So that's so cool because it means that given enough time, given enough particles and just space, the things that are very unlikely will eventually happen occasionally because probability is weird. It's very unlikely that I will win the lottery, but it is guaranteed that some person will win the lottery, right? So that's why I don't buy lottery tickets. It's probably not going to be me. Um, but so let's talk about what that actually means. So the classical interpretation of the wave function in quantum mechanics is that an observer will collapse the wave function to the thing that we observe. So that's kind of the double slit experiment where if, we or a detector or some ephemeral observer is interacting with a particle, it will choose, and I'm putting in quotes because it's not really choosing, that it will choose a particular outcome. Okay, so there leaves a lot to be desired in that, right? Because, like, what is an observer? What does it mean for the particle to choose? Open, but we have to interpret this, right? Because we have the mathematical equations, and then we're like, okay, what does that actually mean? But I was talking with a really rad physicist, Kitty Young. You should follow her because she's amazing and brilliant. And she was telling me that a modern interpretation that's kind of coming up is that instead of the wave function collapsing to one specific outcome, we observe, well, all possible outcomes are happening simultaneously, and what we observe is the most likely outcome. And, there's also a lot to unpack there, but that's so cool. I love that. And I really love thinking about the fact that, like, there really is some randomness baked into the universe. And even though things are very, very unlikely, they will happen eventually. Yeah, it's just the mystery and the wonder of the universe constantly astound me. And I wanted to share that with you. All right. Thanks for watching. Bye.